The question for Boyle's law is a sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atm. What will the volume of the gas be at a pressure of 0.987 atm if the temperature remains constant? So the equation for this problem is P1 times V1 equals P2 times V2. And we're trying to find V2, so like algebra, divide P2 to each side. So then the equation becomes V2 equals P1 times V1 divided by P2. And then you're going to plug it in. So it will be 0.947 atm times 150 milliliters divided by 0.987 atm. And then the atm cancels out, and the answer will be 144 milliliters O2.
That was okay, bro.
The problem for Charles' law is a sample of neon gas occupies a volume of 752 milliliters at 25 degrees Celsius. What volume will the gas occupy at 50 degrees Celsius if the pressure remains constant? So the equation for this problem is V1 over T1 equals V2 over T2. So what we're trying to find is the second volume. So, like algebra, you're going to multiply T2 to both sides. So then the equation is going to be V2 equals T2 times V1 divided by T1. And before you plug it in, the degrees always have to be in Kelvin. So you add 273 degrees to the initial temperature. And so what you're going to get is 298 degrees Kelvin and 323 degrees Kelvin. And so now that you plug it in, it will be 323 Kelvin times 752 milliliters divided by 298 degrees Kelvin. So these are going to cancel out, and your answer is going to be 815 milliliters Ne. So the question for Gay-Lussac's law is the gas in a container is at a pressure of 3 atm at 25 degrees Celsius. Directions on the container warn the user not to keep it in a place where the temperature exceeds 52 degrees Celsius. What would be the gas pressure in the container at 52 degrees Celsius? So the equation for this is P1 over T1 equals P2 divided by T2. So we're trying to find P2. So you're going to multiply T2 to each side. And those cancel out. So then the equation is going to be P2 equals P1 times T2 over T1. And then before you plug it in, you got to convert the Celsius to Kelvin by adding 273. So it would be 25 plus 273 equals 298 Kelvin. This one equals 325 Kelvin. So then you plug it all in. And these cancel out. And when you multiply and divide it all, the answer comes out to 3.27 ATM.